the moment we've been waiting for this chapter, getting into some proofs. So first of all, we've talked when lines are parallel and are cut by a transversal, we have different types of angles, right? We had corresponding angles, alternate interior, alternate exterior. And remember, those are all congruent, right? Corresponding were congruent, alternate interior were congruent, alternate exterior were congruent. Then we had consecutive interior that added up to 180. They were supplementary. Okay, well, now we're just going to reverse the roles. So instead of saying I have parallels first, we're going to have the converse of the corresponding angles postulate, which states if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So basically, I don't know that M and N are parallel, but if I have two lines, M and N, that are cut by a transversal, and I can state that one is congruent to two, then I can say that M is parallel to N because they are corresponding angles. It's the converse of the corresponding angles postulate. So we can use that in a proof now. Right? If I can show that corresponding angles are congruent, I can show that lines are parallel. So it's just the opposite or the converse of what we learned before. Because before we had parallel lines and then we stated they were congruent because they were parallel. One quick postulate here. The parallel postulate, if given a line and a point not on the line, how many lines do you think could go through P that are parallel to M? Well, one line, right? There's only one line that exists that's parallel to M. So if given a line and a point not on the line, only one line exists through that point. That is parallel. Whoop, can't combine that is. That is parallel. That's all there is to that. Okay, now going back to that converse of the corresponding. Well, we have the converse of the alternate interior and the alternate exterior. So basically, if I have two lines that are cut by a transversal, and I do not know they are parallel yet, this is different than what we're thinking before, I could say that they are parallel if I had alternate interior angles congruent. For example, measure 3 congruent to measure of angle 6. Or if I had the other alternate interior, 4 congruent to 5. If I stated these were congruent, then I could state that M is parallel to N. Same thing for alternate exterior. If I say alternate exterior are congruent, then I could state that M is parallel to N. So if I said 2 is congruent to 7, I could say M is parallel to N. If I said 1 is congruent to 8 somehow in my proof, I could say M is parallel to N. And lastly, thinking outside of congruences, the consecutive interior converse. So now if I show the consecutive interior add up to 180, so like 4 and 6, if I showed they add up to 180, or if I said 3 and 5 added up to 180, I could say that M is parallel to N. We also have the converse of the perpendiculars. So before, if I had parallel lines and a line was perpendicular to one of them, then it was perpendicular to the other. Well, now it's the opposite way. If I have one line perpendicular to another and another line perpendicular to that same line, so I said M is perpendicular to R and N is also perpendicular to R, then M and N have to be parallel. The perpendicular transversal converse. So transversal that cuts through as a perpendicular. So let's use this now. Let's try to do a proof here. So given ABC is congruent to ADC. I'm going to mark that. ABC is congruent to ADC. And then A, measure of angle A plus measure of angle ABC equals 180. So we're looking at A and ABC. These two guys add up to 180, don't they? So they're not congruent. I shouldn't do that. But I just wanted to picture that. And we want to prove that AB is parallel to CD. Okay, well, let's start with our given right away. Given angle ABC is congruent to angle ADC. And we always start with our given. And we're also given that measure of angle A plus the measure of angle ABC equals 180. All right, where do we go from here now? Well, let's see. We always use what we're given, don't we? Can I use anything can I do anything with what I'm given here? Well, if I notice ABC is equal to ADC, so couldn't I plug in ADC for ABC? That's one thing I could do. Well, before I do that, if you notice I have this in an equation, so I have to get this to an equality. So let's do that first. So measure of angle ABC equals measure of angle ADC. And that's our definition of congruence, or congruent angles. Now I can substitute it in, and let's see if that helps us. That's my first advice. Always use the given and see if it helps you. You may or may not use it, but it's a good idea. So now we're substituting in, right? So I'm going to say measure of angle ADC instead equals 180, and we substituted that in. So let's see if that helps us. Let's look at our picture now. Sometimes it helps to draw in your picture a little bit. So I want to prove that AB is parallel to CD. I'm going to extend those parallel lines out. AB is parallel to CD. Well, in order to say that they're parallel, I got to use one of my four things, right? Corresponding, alternate interior, alternate exterior, or consecutive interior. So now I got to look, do they have a transversal going through those two parallels? Yeah, I got one through BC here. And I also have one through AD. Well, that's where I'm at right now. Through AD. Because if I notice this, I said that angle A, right here, and angle ADC, measure ADC, right here, didn't I just say that they added up to 180? So really, I can ignore this segment that's going through BD, can't I? I can ignore that guy. Does that help us visualize that a little better? Well, if you notice, AB and CD will want to be parallel, and there's that blue transversal going through. 1 and 2 are consecutive interior, aren't they? And I just stated that they added up to 180. The consecutive interior angles converse. So that's where we're going with that. So now that I've stated that they add up to 180, I can say, because of that converse of that theorem, that those lines are parallel, can't I? I can say that AB is parallel to CD. I can say consecutive interior angles converse. So anytime you're proving that lines are parallel, you're using the converse of one of those theorems. In this case, consecutive interior angles. So now that I showed that 1 and 2 added up to 180, they're consecutive interior, which makes AB parallel to CD. Like I said, the more proofs you do, the easier they're going to become, the better you can think through them. So get after them.